Okay, so question 1. Calculate the magnitude of the electric field at the point that is located 15 centimeters directly north of a point charge where Q, or the charge, equals a negative 15 times 10 to the power of negative 6 coulombs, when K, which is Coulomb's constant, is 9 times 10 to the power of 9 meters squared newtons over Coulomb squared. So when we're calculating this, the first thing we want to do is the magnitude of an electric field and use a single point charge, which is given by E equals K Q over R squared. Okay, where E is the magnetic field. 0.15 meters, because our centimeters cancels out. Okay, so from here, let's take that charge and the distance in the equation and solve for the magnetic field strength. Okay, so we're going to be using, let's rewrite it, our E equals constant Q over R squared. Or as I said before, E equals the magnitude of the electric field. So we're going to take E and just plug in equals K, which is what? 9 times 10 to the 9 meters squared newtons over Coulomb squared, multiplied by that negative 15 times 10 to the negative 6 coulombs over 0.15, which we just calculated, which is the distance squared. Close our parentheses. Now we're going to multiply out. Bring down our E equals. Okay, so we're going to first work on our parentheses according to PEMDAS. All right, and we're going to divide these two first. All right, once we divide out, we're going to bring down what we have left. 9 times 10 to the 9 all right, and so once we convert our given, as I said, to get the magnitude of the electric field, and to have that meters squared newtons over Coulomb squared multiplied by a negative 6.67 times 10 to the negative 4 coulombs over meters squared. All right. At this point, we simplify further. E equals a negative 6.0 multiplied by 10 to the 6 newtons per coulomb. Okay, and that will be our answer. All right, let's try a different problem. A 9-volt battery is connected to a circuit. The measured current is 2 amps. what is the equivalent resistance? For this problem, we're going to use Ohm's law. Which Ohm's law is V equals I R, where V is the voltage, I is the current, and R is resistant. We're given the voltage and the current in this problem, okay? This allows us to solve for the resistance, so we just plug in. We get our 9 volts equals I, in this case, 2 amps, multiplied by, which we don't have yet, R, which is our resistance. This is what we're trying to calculate. So we simplify now. And we get 9 volts equals that 2 amps, which we brought down because if we're multiplying here, we're going to divide on both sides. And that gives us 9 volts over 2 amps equals resistance. Okay, when we calculate out, we get 4.5 ohms equals our resistance. And there's the answer. All right, let's try another one. What is the power of a circuit with a current of 15 amps and a resistance of 10 ohms? The standard equation for power is P equals IV. Okay. Well, I is our current and V is our voltage. So at this point, we're given the current and the resistance. Now we want to manipulate the equation so that only the variables are given, and then we can substitute Ohm's law for voltage. So we have our V equals IR, which is Ohm's law. Okay, so we're going to take P, which equals our I, V, which in turn equals I multiplied by I, R, which gives us what? IR, but there's an I squared now. Now we have the equation for power, and we just simply plug in. So we have P equals our 15 amps squared, because that is our current, okay, multiplied by what? Our 10 ohms, which equals 225 amps squared multiplied by the 10 ohms equals, then we simplify this and we get 2,250 amps squared ohms, which this unit is the same thing as watts. And there's our answer. Thank you.